My name is David Lublink, and I am passionate about technology. I'm a huge Trekkie. My home router, obviously, is running Hashistack. I'm currently developing a YouTube series on a number of important topics for new and experienced DevOps. Amongst other things, I'll be doing in-depth coverage of Hashistack. I'm also a director of developer operations at Cloudly Communications. Who are they, you ask? Well, information overload. I'm not going to go through this whole thing, but basically Cloudly does cloud communications, which, as you can imagine, means there's real-time voice, fax, and other media. But what I like about this page are the words flexible, reliable, simple, secure, efficient, and cost-effective. These are some of the things that I share with Cloudly, and it's why Hashistack made sense for both of us. And you're going to see why in this presentation: infrastructure, post-merger, solving key technology challenges with Hashistack. So what is Hashistack? It's a lightweight, flexible, scalable. It provides automation, it does orchestration, it does security, and service discovery. Let me put it another way. Hashistack has three main components: Vault, Consul, and Nomad. In this setup, Vault provides secrets management, including certificate signing and password rotation. Nomad deploys your workload to wherever the capacity is available. And finally, Consul will publish health information about the services, as well as publish the location of the services. When deploying Hashistack in a small redundant setup with 3 server nodes and 3 clients, you would install Consul, Vault, and Nomad on each server. The clients don't have Vault, they only have Consul and Nomad. And in all the installations I've ever worked on, the main driver of Nomad has been Docker. So I've added that to my drawing. Note that the Nomad clients are the nodes that are running your workload and not the servers, as the servers are responsible for tracking the state of the cluster, figuring out where they can deploy new allocations based on available resources and constraints. It might seem as scary at first when looking at this drawing, as you now potentially have 3 new technologies to manage: Nomad, Consul, and Vault. However, if you install Vault first, which I would argue is probably the most difficult of the 3 because of mandatory policies and certificate management, you'll find that Consul is quite easy to configure and bootstrap. And if you have Consul running and Vault running, you can have Nomad bootstrapped quite quickly, as it will find the nodes through service discovery. In this drawing, we zoom out of our Hashistack and we see it as seen by the job writers and VIPs. From here, you can see the first 2 components I like to add to a Hashistack cluster when I'm in a professional environment. Here I've used Jenkins, but you can use whatever CI/CD software you want to use. In this case, Jenkins is in charge of building images, fetching Nomad jobs from source control, doing any transformations needed on the job, and of course the most common transformation we're seeing is replacing a colon latest for colon whatever the build number is. The last but most important job of Jenkins is to gatekeep Nomad in this drawing. When you run a home Nomad cluster and you only have 1 or 2 users submitting jobs, Jenkins might be overkill. But when you're in a professional setting dealing with especially developers who are good at bypassing technology, it's a good strategic choice to have Jenkins being the one submitting your jobs to the cluster. And 2 reasons for that: it gives a clear path for a developer to deploy, and developers typically know how to use Jenkins. But 2, if it's handled by Jenkins, that means that you can now automate submission of your job to that cluster. The second major piece added here is HA proxy. Now, like Jenkins, this is a preference. Go with what you're most comfortable with, whether it's Nginx, Envoy, or something else. In this setup, HA proxy has a local console client running on it, and when HA proxy receives a request from a VIP, for example, for corporate.example.net, HA proxy is going to look up in Consul for that service, and we'll find perhaps WP service console, which will be run in the network, and it'll route the request to whichever WordPress is available and send that to the user. Now, you might think it's a funny choice to use WordPress in this example. And the reason I chose this one is something I found is that Nomad jobs aren't only being written by developers. In fact, they can come from pretty much anywhere in your organization. So for DevOps, the obvious software DevOps might run in a Nomad cluster, in a Hashistack cluster, would be something like an Ingress proxy, like we just talked about, a Jenkins, maybe a Prometheus, or a Wiki, or something else. As someone running a Hashistack cluster, you want to be on the lookout for employees trying to set up automation or other software because they may not think to reach out to you. And so that's why I actually chose WordPress for this example, just to kind of beat home that yes, while developers are kind of your main market for getting jobs into your cluster, pretty much anybody can produce one. So be sure to keep your eyes and ears open. So I have an example here real quick. I have a developer who asked me for 2 independent Redis instances that run on a static port 6379. I said, okay. So on the left, you can see I did a Nomad job. I've called it Redis Cache, and I have a group called Cache. I have a port called DB that's going to be listing on the static port 6379. And all of that is going to be using the Docker driver. We're going to be using the latest image of Redis, and we are going to be listing on port DB, which we define as 6379. And finally, we're going to be registering to Nomad a service called FunRedis, and it's going to be that DB port. And you can see here at the top, this clip from Nomad, you can see I have these 2 allocations running. And at the bottom, you can see that, Consul knows what's going on, the service health checks are passing, and you can see that it knows the IP address and port. Now, if the developer had asked for a non-static port where the port will be randomized on each deploy, they might use a DNS SRV lookup to find the port, or they might be using a Consul template in order to configure their service. So how does Hashistack improve culture? Well, first, it's going to lower the cost of deployment, because the first deploy is going to take a little bit more time because you might have secrets to configure in Vault or configurations to make in Consul. But once you've gotten a service deployed, updates to that service are going to be very easy generally, because most of the time you'll just be resubmitting the job with maybe a new Docker image version or maybe some minor changes to a template or a variable. But you submit that to the cluster and Hashistack will take care of the rest. With the deploy path established, releases become more consistent and reliable, and so now you can move faster. A real-world example, before we moved to Nomad, I had a portal that when we would deploy it, pre-Nomad, it would take at least an hour to deploy it, to fire up the virtual machine, configure it. We needed a dev and a DevOps on the call to get this thing deployed. We'd wait. It would take time. When it'd get up, we'd log in, we'd do some testing. And if we're happy, send it to QA and then rotate that in. Now with Nomad, that process that used to take at least an hour is now taking minutes, and it is all automatic. And so faster deployments means developers can get feedback from the customers faster. If it takes 3 months to get feedback, well, the developer's probably working on something else. If it takes 3 hours to get feedback from the customer, the developer is going to be engaged. The developer will be happier because their work will be in the hands of the customer sooner. So I don't want to start a flame war, but Hashistack is better than Kubernetes for my use case, and hopefully for many of you who are listening today. Now, I don't know if Gustavo from the chat is still around. He asked earlier, so is Nomad a substitute for Kubernetes, or does it work together? In my presentation today, it's well, I guess you could call it a substitute. I'm not using Kubernetes. I'm using Nomad to do my orchestration. So a few things about Hashistack, and especially Nomad, that I appreciate is that when you're working with Nomad jobs, the jobs themselves are white space insensitive, which means that I can cut and paste bits and pieces of Nomad jobs. I'm not starting a holy war there, Marco. I can cut and paste bits and pieces of Nomad job fast, and at the end, just run Nomad format, and the job is formatted. I don't have to worry about realigning the pasted code as I go because I just run that Nomad format. On Nomad clients, the Nomad and Consul clients barely register most of the time when looking at top processes. It's rare that they'll use more than 1% of your CPU. And generally, if it's using more than 1% of the CPU, it's probably because it's doing a deployment, and most of that CPU is going to be consumed by artifact downloads, such as a Docker image or other artifacts. Nomad's simple to manage, maintain, and upgrade. And so if you want to pick sides, just listen to what I'm about to say. I once heard a Kubernetes user say, I've thrown away entire clusters and spun up new ones just to avoid an upgrade. Let that sink in for a few seconds. On the other hand, I once did a upgrade of a Hashistack cluster that was actually 3 clusters that had about 50 nodes, and we were moving about 3 major versions because, I mean, we hadn't, really updated in a while. And so if you know how to update this, you'll know that you have to do 1 major version at a time. And so that came out to about 150 updates. Took about 90 minutes to do the whole thing. And I mean, it only took that long because we were taking our time. So for me, those are some of the things I prefer about HashiStack and over Kubernetes. Now, if you go on Google, I'm sure you can find plenty of more reasons. And as some people said in the chat, we're not trying to start a holy war here. We're just, I'm just saying I like HashiStack a little bit better, or a lot better than Nomad. So let's jump into then that merger we were talking about. So I already introduced Cloudly. So as you can imagine, each of these companies that merged had, similar markets and similar customer bases. In fact, from a business analyst point of view, all 3 companies were basically the same. And all 3 companies, uptime or reliability was the #1 concern. So all 3 companies should be the same, right? Nope. So in math and logic, an axiom is a statement accepted as true without proof. In DevOps, we have our own axioms, beliefs that are rarely questioned but influence our decisions. Let's explore what happens when 3 companies combined with each their own axioms and egos. So all new servers should run Linux. This first axiom was shared by all 3 companies. So let's look at a Venn diagram of this technology. Yay, look at how happy Tux is there representing new Linux. Oh, this beautiful Venn diagram is really bringing a tear to my eye. I wonder if all 3 companies use the same distribution. Uh-oh. Ubuntu OS is the right Linux for our needs. Okay, so I guess we have 3 different companies using 3 different distributions. So now there's some discord because these once unquestioned axioms are no longer given. If each company has different Linux distributions, I wonder what other differences they have. Cue ominous music. Maybe we should try another Venn diagram. Databases and distros and proxies. Oh my. Databases and distros and proxies. Oh my. Okay, we're not in Kansas anymore, but each circle represents one of the 3 companies. Inside each is a technology each one used. And as you can see, beyond new Linux and SSH, there's not really much overlap. And when you look at some of the overlap between these companies, it's interesting is that they did things very differently with those softwares. And so while there is overlap, it's not as overlapping as you think. And so now imagine you're on that team and you suddenly have to learn 3 different ways of doing the same thing. That's a lot. Well, at least we're using standard tools that everybody knows, right? Right? Uh-oh. I don't know if anybody here has ever heard a tech person say this sentence. It'll be faster if I write my own implementation of this software than to learn how it works. Really? Really? You think it's going to be faster? Come on. No, it won't. I remember a few years ago when I was looking for a good CI/CD system, one of the guys I was working with convinced me to use Jenkins instead of writing my own implementation. You know who you are. Thank you. He graciously pointed out that while I could write a tool pretty quickly, with an established tool, I could get that ecosystem of plugins, documentation, and online community. If you run your operations in the handoff style, where operations installs a virtual machine OS, maybe a firewall, and then they hand that off to the developer and says, do your thing, you'll end up with a lot of custom tools appearing, whether it's scripts to automate portions of the installation, scripts as part of a manually executed failover plan, or even, a quite complex service health management system. You'll end up with bits and pieces of automation all over. But with the merge, you now have 3 different but entirely incompatible versions of 10 different wheels. So, you should only ever reinvent something if you absolutely have to, because every time you reinvent something, you're creating a new software and system that has to be maintained into the future. And the bigger the system, the more costly the maintenance. And then you here's some more flashbacks for you there, Chris. And then you hear, we've always done it this way, and it's always worked. Therefore, we must continue to do it this way. Or if my company Stacks wins, it proves we were the superior company. So the following is a dramatic representation of the turf war that followed, and apologies to Ethel Merman, Doris Day, and to anyone listening who may suffer from spontaneous song aversion syndrome. dun, 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 dun. Any Linux you use, mine is much faster. Debian's king and the rest are disasters. No, it's not. Yes, it is. No, it's not. Yes, it is. Any stack you can build, I can build faster. I can scale better with failover master. No, you can't. Yes, I can. No, you can't. Yes, I can. Yes, I can. I can deploy a VM with a single bash script. I feel like this isn't landing. Is this Keshaf? You're going to have to tell me if that landed, but maybe this audience is too young for that kind of thing. So let's try something different. And may the odds ever be in your favor. Did I get that right? Y'all imagining that savage turf war that's happening yet? All right. So maybe not savage, maybe a little bit exaggerated, but still, when you have competing tools, each team pushes their own stack. This creates friction, which slows progress, wastes time, money, and resources, which hurts morale and kills innovation. And so now you're thinking, how does Hashistack solve any of that? And so, well, one, since Nomad can run most software, you can easily deploy any of these different tools that are needed by these different groups. Hashistack offers solutions to common problems such as service health checks, automatic service restarts or watchdogs, secrets management, no more secrets in Git, etc. Docker is going to dilute the OS debate. If I can have any OS-based image in my Docker container, I don't really care what's happening outside the container anymore. And for when your developers are offered Hashistack, they're empowered because they can more easily deploy their work. But most importantly, when you're combining 3 businesses and 3 tech stacks, your developers won't have a lot of spare cognitive load. You need something easy. As a DevOps engineer, you'll likely be the one to create the first Nomad job for your developers or provide them with templates. Generally, a developer won't need much more than environment variables, maybe an entry point override and some templates for most jobs, i.e. not much to learn, low barrier of entry, shallow learning curve. Let's talk now about deployments and redundancy. So here's another terrifying quote I'll never forget. Let me just log into the server and I'll take care of it. And if that doesn't cause you to be afraid, well, you have a stronger stomach than I do, I guess. As I was trying to build automation for a particular server type in one of these 3 companies, I came across the following description for deploying a new server. Well, and so I'm going to be quoting somebody here. This wasn't me, but and it's paraphrased a little bit just for simplicity. Well, you see, I, Alice, go in and install the new servers, wire them up and install the OS. And then I pass it off to Bob. He logs in, does stuff, and he passes it off to Frank, who logs into the server, configures some software, sacrifices a hamster to Hephaestus and a squirrel to Hermes, and then he sets the password on all the SSH users. Okay, well, maybe there were no animal sacrifices, but I kid you not, 3 different people were each doing their own thing without really knowing what the others did. And so I thought, well, let's go look at those production servers and see what we can find. And what I found is that not a single server was the same. Each one had subtle differences, and sometimes it's the software packages that were different. Sometimes there were configuration differences in business critical software. All right, and if that isn't scary enough, what happens if I lose one of these servers? Better hope I have good backups. I can't reproduce this thing. Yes, no hamsters were harmed in the making of this talk. We've already talked about how Nomad automates deployments once you've submitted a Nomad job. Here, what we are adding is version control. Generally, I encourage people to store their Nomad jobs in the same repo as their code. Now, before anybody says something in the YouTube chat, I would add that if you're dealing with a much larger and more complex job, it might not make sense to have the Nomad job in the same repo, but your Nomad job should always be, in a repository somewhere, whether it's Git, Subversion, or something else. So the Nomad job contains the definition of the expected end result, not how to get there, just the end result. So Nomad can look at your job and it looks at its available resources and it'll find a way to fit you in. It can fetch resources from Vault and Consul as needed, and it'll build up that space and fire up your containers. And of course, Nomad provides easy tools to increase the number of allocations and control how failover happens when an allocation fails or is lost, which means it's easy for developers to build redundant systems. So let's go back to that story I told a few moments ago, so what's changed? Well, now when I chase down all those pieces of that deployment, I can stick it into a single Nomad job. I'll have a single point of reference, a single source of truth. Something that Nomad, and so I talk about Nomad here, but really we're talking about Hashistack in general. But something that I really like about Nomad is it puts a little bit of a line in the sand, and it makes it easier to track responsibilities. You know, the developers, they're going to write their code, they're going to maintain their Nomad job, and you can think of the Nomad job as just packaging their software. And so the DevOps operations group, they can run the Nomad cluster. They'll ensure there's enough capacity, run the different jobs that have been allocated. And if the developer needs something special, they can reach out to DevOps and say, hey, this job I'm working on, I'm going to need a new volume or something like that. And so the DevOps team can prepare that, and they can send a sample Nomad job to the developer saying, hey, just copy out what you need from this, and you'll be able to use that new resource. So we're moving on, and we need to talk now about the gatekeepers of production. And what are the gatekeepers of production? Well, pre-merger, you might have one guy who's your product owner, network operations, support, another person who might be sales and marketing, and then support, quality assurance, and compliance might all be the same group. You don't have a lot of people when you're a small business, and so getting consensus with 3 or 4 people, it's pretty easy. But when you are suddenly much bigger and you have a lot more people, and each of these roles is a single person or group, suddenly it's a lot harder to get consensus. In fact, and when you do finally get consensus that your software is ready to be deployed, then the question is, does anybody really remember what was tested? And so that brings us to, well, if you get your Hashistack right, and you fully automate your processes all the way from git push all the way to it's deployed to production, introducing manual triggers only as the business requires, not as technology requires, you'll find that your production gating process can be simplified to, when the team is ready, just press this button. Now, you're probably thinking, all of this sounds great. I want to see this thing in action. So I'm going to do a quick demo for you here. And we're just going to talk about a developer who came in, and we're going to start with that scenario we had earlier in the presentation, where the developer comes in and says, hey, I need a Redis cache. And so I'm going to pull in this job, and we're going to walk through this real quickly. So I have this basic job. I'm calling this Redis cache 2. I have a group called cache. I have a database port 6379. We're using Redis latest. We are going to be, opening up the port into my container, and we're going to be announcing this onto Consul. If I go click into Consul, you can see that I don't have any Redis registered. And so I go ahead and I hit plan. It tells me how this is going to affect my cluster. And in this case, well, we're going to create something. Oops, I hit cancel instead of run. I hit plan, and it starts up. It is... it's already running. It's so fast. And now if I go back to Consul, you can see now there's this Redis service that's been registered. You can see the IP address and the port that's registered to. We don't see the demo environment, can't see the console. I am on the wrong screen. I apologize so very much. Let me try that one again. So we've done a short, Can't see your screen. Yes, I know. Now you can see it, right? So we're saying that I have this job. We're calling this Redis cache 2. We're saying port 6379. We're going to be calling this DB. We have our Redis image, and we are going to be opening up port to DB and announcing this to Redis. Now I'm just going to stop this job so that you can see that this console I had opened up a moment ago when the screen sharing was where it was. You can see that I don't have any Redis in my console. So I come back here, and we're going to say we're going to run this job that we just reviewed together. We're going to call this Redis cache 4. And you can see how it affects the cluster. Well, we're going to create this new job. And so we hit run, and it deploys. Hi. And so here we can see that my Redis cache has deployed. Now I could connect to it, but I actually want to move on to the next part of this demo. So we had this up and running, and if I click on allocation, I can see the zooming of this page has broken the UI a little bit, but you can see that this is the port my service is listening on. And of course, in Consul, you can see if I click on Redis, you can see that it's the port 27185 on this IP address. And so we say, okay, well, that's all well and good. That seemed too easy. Let's try something a bit harder. And oops, that's not the one I wanted. I want to stop this one up here. And so we say, now the developer is asking for a secure database, needs to be MySQL, and he said no passwords. And I'm like, okie-do. Let's see what we can do with all that. And so this time we're going to be involving Vault and a Consul, and I will walk you through real quick. So the first part looks similar. I've got a name on my group, I've got a name on my task. I'm going to be using Docker once again. I will be using the MySQL latest image. And something a little bit different this time around is that I am invoking a Vault policy. I'm saying that whatever happens in here, I will need some privileges inside of Vault. And so if I go up into Vault, we can see that I have a policy called database demo that's going to allow us to request a certificate be signed using the role database. After that, further down in my Nomad job, I have these template stanzas where I say, hey, with secret, that's code for go see Vault. We said, go sign that certificate. Let's maximize that. We have my common name, which is going to be database.service.consul. And you can see that I've broken that into the private key, the CA, and the certificate. Like our Redis instance, I have a port 3306 we're calling a DB. And then finally, well, actually, there's two more things left. I can't say finally yet. Here we're saying, tell MySQL that we need SSL and that we're going to be using this to identify ourselves to incoming connections. And we'll be using this list of CAs to identify certificates provided by incoming connections. And I have this base SQL. If you know MySQL Dockers, anything in this folder will be executed on server startup. So finally here, I say we're going to create a new database, HashiTalk 2025. We have the user application, which we're going to be using a certificate for identification. And we're giving access to this table. And of course, we have some data going into this database. And we're going to just type keyboard smash and some random keyboard smash. And finally, we have a root password, but this could have been in Vault, but for today's demo, we're just going to not care too much about that part. We're going to hit plan, and anytime you hit plan, it's going to tell you, well, this is how it's going to affect the cluster. Now, it is true that there is a CLI. All of these things I'm showing you right here, you can do with CLI, and when you're integrating something like Jenkins or anything else, you'll probably be using those commands, but I just really like the UI on Nomad. So we're going to be spending the demo mostly in here. And so here you can see I have my new allocation that is up and running. And when I click on it and I go into files and local, I can see that I have my certificate. I can see that I have the root certificate we're using to identify people. And if I try and click on secrets, you can see the key is there, but of course it won't let me read it because that's a secret. So I have this MySQL job up and running, and now the developer is saying, hey, how do I use this? And so I have a very, we're going to go over this very fast because I'm out of time, but we have a PHP job that's mostly just pulling environment variables and configuring a MySQL PDO object. And then we pull the columns and we output that. And so this is going to bring us to our last job. The last job is going to look a little bit like the database job. I forgot to go over this, except the different policy. This time we are a consumer, different image. I'm going to be listening to a web port. I've configured my secrets, my certificates. And of course, we have the same style for pulling all of our certificates from Vault. So we're going to plan this. We're going to run this. And it loads up fast, yay. And if we click it, we'll see that it says connected successfully with SSL. Hello, HashiTalks. And you can see that keyboard smash that we did moments ago. And you can see that it's that easy. Something as complex as certificate signing and all that, comes out to a couple of lines of code in here. So it's really, really easy, even certificates. So what's next? You need to go ahead and spin up your own Hashistack cluster today. Start with Hashistack. I recommend starting small for experimentation. If you're for experimentation, learning, and home networks, one server, one client might be fine. But if you need redundancy, start off with 3 server nodes, 2 client nodes. The clients do redundancy a little bit different than the servers. The servers are using something called Raft, where you need an even number of servers. An odd number of servers, and you have to have at least half of them up for your server to survive, your cluster to survive. But the node clients themselves, since it's doing your workload, it's going to be scaling and fault tolerance differently. So you can get your fault tolerance with just 2. Start with low risk, easy services, anything that is low impact, start with that, build confidence in your Hashistack cluster. And then once you've done that, then you go to the opportunistic migrations, such as targeting unstable systems, or, anytime somebody says, I have to do a major update on this, or even a minor update on that, say, hey, let's just move that into Hashistack while we're at it. Expand your Hashistack. Yep, Vault, Consul, Nomad are just the beginning. Terraform is going to automate your infrastructure deployment, so your Nomad clients and servers can be deployed through Terraform. Packer is going to let you build those images you're going to be using with Terraform. We already talked a lot about CI/CD, so I won't go back over that. Nomad Pack, this is going to allow you to do more advanced templating of your Nomad jobs. If you need something more complex than search and replace :latest for : my tag, Nomad Package is the way to go. And of course, Nomad Pack Registry. If you look this up, there's a number of common Nomad jobs that you can probably use to get your Hashistack cluster going up and running faster. So automate everything with Hashistack, because that'll let the developers connect with the customers. Automate everything with Hashistack. All right. Thank you for watching. Be sure to check out my YouTube channel. Yeah, thank you.